We're now going to walk through an example where we're going to evaluate a definite integral using the limit definition. This is a difficult problem, but don't worry, I'll walk you through it step by step. We're going to evaluate the definite integral using this limit definition and these formulas. The limit definition of a definite integral is the integral from a to b of f of x dx is equal to the limit as n goes to infinity of the sum I is equal to 1 to n of f of x sub I times delta x, and x sub I is a plus I delta x. The formulas that we need to use are listed in this second box. We have the sum, I goes from 1 to n of a constant, and then we have the sum of I, and then I squared, and I cubed. And we'll use these in just a minute. Here's the example that we're going to do. We're going to evaluate the integral using the limit definition. The best way to begin is to start out by writing down what the limit definition is. Our integral using our limit definition is the limit n goes to infinity. The sum I goes from 1 to n of f of x sub I times delta x. And let's write down that x sub I is equal to a plus I delta x. Let's now find out what delta x is. The formula for delta x is b minus a all divided by n. If we look back at our integral, we can see that a is 1 and b is 3. So this gives us 3 minus 1 all divided by n. So this is 2 divided by n. And now we can write down what x sub I is. X sub I is then a, which is 1, plus I times delta x, which is 2 divided by n. Now we're going to substitute in f of x sub I and delta x into our limit. F of x is this function here, 2x minus x cubed. So let's go ahead and put that in. This gives us the limit as n goes to infinity. The sum, I goes from 1 to n. F of x sub I is now 2 x sub I minus x sub I cubed. And then our delta x is just 2 divided by n. Now we're going to substitute in this expression for x sub I. This gives us the limit as n goes to infinity. The sum, I goes from 1 to n, 2 times x sub I, which is 1 plus 2I over n, minus x sub I cubed, so this is minus 1 plus 2I over n cubed, and then all of this gets multiplied by 2 over n. I think what makes this problem so hard is there's just a lot of algebra to be done. Notice right here that we are going to have to cube 1 plus 2I over n. To make things easier, let me write down this formula. A plus b quantity cubed is equal to a cubed plus 3 a squared b plus 3 ab squared plus b cubed. Now we'll go ahead and let's use that. This gives us the limit as n goes to infinity. The sum, I goes from 1 to n, of 2 times 1, so this is 2, and then we have a 4i over n. Now we're going to subtract off 1 plus 2i over n cubed. Let's also write over here that a is equal to 1, and then our b is 2i over n. We have a cubed, so that's just 1 cubed, and that's 1. And then we have plus 3, a squared is 1, times b, which is 2i over n. and then we have 3 times a, which is 1, and then we have b squared, so this is 2i over n squared, and then we have b cubed, so this is 2i over n cubed, and all this gets multiplied by 2 over n. Now let's go ahead and multiply everything out. This is the limit, n goes to infinity. The sum, I goes from 1 to n. Let's see what we have. We have 2 plus 4i over n minus 1 minus 6i over n minus 3, and then 2i over n squared is 4i squared over n squared. And then we subtract 2 cubed, which is 8. So this is 8i cubed over n cubed, all times 2 over n. I think the biggest mistake I see students make, and sometimes I make too, is to not pull that negative through to all 4 of those terms. What we're going to do now is we're going to combine like terms. So we have our sum. Let's first combine our constants. We have 2 and minus 1, so that gives us a 1. And then let's combine our I terms. We have 4 minus 6, so this is minus 2i over n. Now let's look at our I squared terms. That is minus 12, so this is minus 12i squared over n squared. And then our last term is our I cubed term, and that's a minus 8. So we have minus 8i cubed all over n cubed times 2 over n. We are running out of space, so we're going to have to continue on to the next page. So let me just go ahead and let me grab this, and we'll put that on our next page. I went ahead and copied the formulas that we're going to need also, just to make it easier. What we need to do now is multiply all 4 of these terms by 2 over n. So we have the limit, n goes to infinity. The sum, I goes from 1 to n. The reason that we're multiplying through by 2 over n is we're eventually going to have to take the limit that involves n, so we need to have all the n's combined. This gives us 2 over n minus 4i over n squared minus 24i squared all over n cubed minus 16i cubed all over n to the 4th. Now we're going to use these formulas right up here at the top. So we're now going to have to distribute our sum to all 4 terms, and then we can use those formulas. This is equal to the limit as n goes to infinity. We'll put a bracket here because we're going to have 4 sums now. We have the sum, I goes from 1 to n, of 2 over n. And for these next 3, I'm going to pull out the constant and the n power because the sum only involves I. So we have minus 4 over n squared. The sum, I goes from 1 to n of I, minus 24 over n cubed. The sum, I goes from 1 to n of I squared. And then our last one is minus 16 over n to the 4th. And we have the sum, I goes from 1 to n of I cubed. Now we can go ahead and use our formulas. We'll have to go up and down here. Let's look at this one first. 2 over n is a constant, so our sum is our constant times n. So this first piece is the limit, n goes to infinity, of 2 over n, that's our constant, times n. Now let's look at our next one. That is the sum of I. So this is minus 4 over n squared times n times n plus 1, all divided by 2. Then we have the sum of I squared. This gives us minus 24 over n cubed, n times n plus 1 times 2n plus 1, all divided by 6. And then our last one is minus 16 over n to the 4th. We have I cubed. There is our I cubed. So this is equal to n squared times n plus 1 squared, all divided by 2 squared, which is 4. Before we find the limit, we need to do a lot of algebra. This is what makes this problem difficult. Hang with me, we are getting close to being done. Limit as n goes to infinity. Our first term is 2 divided by n times n, so this is 2. And then our next term, that's this term right here. 4 divided by 2 is 2, so we have minus 2. Up top, we have n squared plus n. And then in our denominator, we have n squared. Now let's look at our third term. We have 24 divided by 6, so that gives us a minus 4. And now we have to multiply this out. N times 2n is 2n squared, and then we have another n, so this is 2n cubed. And then our outer term is n times n, which gives us an n squared. And then our inner terms are 1 times 2n, so that's 2n, and then we multiply by another n, so that's 2n squared. And then our last term is 1 times n, so that just gives us plus n. And all of this is divided by n cubed. And then we have one more term, and that's right here. This is minus 16 over 4, so this is minus 4. I'm going to divide the n squared on top into the n to the 4th on the bottom, so we just have an n squared on the bottom, and then we have to square n plus 1, so this is n squared plus 2n plus 1. Now let's see what we have. We have the limit as n goes to infinity. We have 2. Now let's look at this term. This gives us a minus 2 minus 2 divided by n. Now we'll look at this term. This gives us a minus 8 minus 4 over n minus 8 over n. And then lastly, we have a minus 4 over n squared. And then we just have this last term. This is minus 4 minus 8n over n squared, so that's minus 8 over n. And then our last term is minus 4 over n squared. Before we take our limit, let's go ahead and let's combine these terms. Our 2 minus 2 cancels, so for our constants, we're just going to have a minus 8 and a minus 4. So this is minus 12. Now let's look at our terms divided by n. We have minus 2, minus 4, minus 8, and a minus 8. So let's see. That is minus 2 minus 4 is minus 6. And then we have a minus 16. So this is minus 22 over n. And then our last terms, we have a minus 4 over n squared and a minus 4 over n squared. So this is minus 8 over n squared. Now we're almost done. When we take the limit as n goes to infinity, this term is going to go to 0 because we have infinity in our denominator. And this term is also going to go to 0. So after all of this work, our answer is equal to minus 12. I think the key to doing this problem correctly is making sure that you double check your algebra as you go along.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.